Dr. Sangeeta Talwar, currently the Director Principal of the prestigious Maulana Azad Institute of Dental Sciences, with which she has been associated from 1987, is an exceptional multifaceted person, yet very modest and sweet, having contributed both as an academician and clinician with equal aplomb. She is an investigator with the Council for Scientific and Industrial Research, that is a CSIR, under which research projects are underway in her department. She is currently the president-elect of the Indian Endodontic Society, fellow of the International College of Dentists, and the Pierre Fauchard Academy and National Academy of Medical Sciences. Professor Dr. M.S. Muthu is currently the chair of Center for Early Childhood Caries Research, Department of Pediatric Dentistry, Sri Ramachandra Institute of Higher Education and Research. He was conferred the membership of the Royal College of Physicians and Surgeons of Glasgow in 2016. He is the Joint Secretary of the Indian Society of Endodontics and Preventive Dentistry and the General Secretary of the Indian Society of Dental Traumatology. He is the chair of Global Task Force on Cleft Without Caries, and he has authored 2 textbooks for Elsevier, including the widely followed textbook, The Pediatric Dentistry, Principles and Practice. He is one of the few researchers in India in the field of dentistry to have held multiple research grants to the tune of almost 6.24 crores. So I now hand over the mic or the podium to Dr. Sangeeta Talwar to introduce our speaker for today, who's a very good friend, have been in association with Dr. Bennett for almost close to 13 years. The first time I met him was in 2007 during the Malaysia conference. So I'm so glad to be part of this, and I'm so glad he accepted this invitation of ours. Over to you, Dr. Sangeeta.
Yeah, thank you, Dr. Mahalakshmi, for the lovely introduction. And now I take this opportunity. You said Malaysia, so even I was there, and I did meet Dr. Amechi there, but not at the personal level. I think it was more professional level that time. But this is more personal, I would say, coming in one-to-one contact with Dr. Amechi. So with your introduction, Professor Bennett Tochukwu, for the rest of us, he's a professor of cardiology in the Department of Comprehensive Dentistry of the University of Texas, San Antonio. He gained his PhD degree in cardiology and preventive dentistry at the University of Liverpool. And he has been successfully leading cardiology teaching and research for 2 decades in San Antonio University, mentoring the careers of many faculty and students within his institution, as well as outside in several countries. Over the years, industrial partners and federal agencies have awarded him about a huge amount of funding to the tune of about $10 million. And he has authored several high-impact journal articles, monographs, book chapters, and as well as a book on dental erosion. Dr. Amechi, you are a reviewer to several scientific journals and grant funding bodies, including the NIH. He has various awards over the years to his credit, and we will only tell the latest one. It is the 2019 Presidential Award for Sustained Excellence in Teaching. Congratulations to you, Dr. Amechi.
Thank you.
He was also awarded membership of, welcome. He was also awarded membership of Faculty of Dental Surgery of Royal College of Physicians and Surgeons in Glasgow in 2016. And as an active member and also of various national and international professional organizations, Dr. Amechi has served the Indian Association for Dental Research as president, president-elect, secretary, treasurer, and group program chair of Cardiology Research Group. Also, he is the chair of IADR Constitution Committee. So as an elect member of the advisory board of European Organization for Caries Research, he has served on the panel panel for development of 4 cardiology curriculum targeted for global adoption. Now, with this, I invite you, Dr. Amechi, for your lecture. Please.
Okay. Thank you so much for the elaborate introduction. So I will now start to share my screen. Okay. Can you see my screen?
Yes, we can, Dr. Amechi, can go ahead.
Okay, sorry that I'm speaking from our media room, so you cannot see my face very well. Sorry, I just want to make sure that everything will go very well. That's why I came to the media room. Well, today, let me start by thanking Dr. Mahalakshmi for inviting me to this great conference. This is my first time of speaking in conference organized by her. But it's my third time of speaking to the Indian audience, you know. So I'm very happy about that. COVID did not allow us to come in person this time around, but in near future, I hope to come to India. Okay, today I will be talking about, the title of my talk is Newer Remineralization Agents. What might the future bring? I wanted to before I start, I want to show you our new dental school. This is our new dental school. It's a very big dental school now with a lot of chairs. And San Antonio as a city has it's a tourist center. It has 2 magnificent centers, or something you will always look at when you come to look for. It's called the one by the left-hand side is the Alamo Center. This is the very spot where the Texas defeated Mexico to take over. America defeated Mexico to take over Texas as part of America because Texas belonged initially to Mexico. And then the second place by the right is our great river walk. It's the only one in the whole America. It's a tourist attraction center. Okay, today I'm going to talk about remineralization. Now, first of all, what do we mean by remineralization? It is a process of bringing minerals from surrounding environments, such as from saliva, from biofilm, from oral mucosa, into the partially demineralized tooth structures. The remineralization I'll be talking today is remineralization of early caries. It's not remineralization of cavitated caries or any stage of caries, but that early stage of the very early stage of caries, it can be reversal of the caries to totally normal, natural tooth structure, or it can be an arrest of the caries just to arrest the progression of the lesion. It is not saline or resin infiltration, which you know about. And you know that when remineralization, some people, remineralization of early caries, some people call it secondary prevention. Primary prevention, as we know, is preventing the caries from occurring at all. But when the caries has manifested at the early stage, the remineralization or control is regarded as secondary prevention, while restoration is regarded as a tertiary prevention. So the very one I will be talking today is the secondary prevention, that is dealing with early caries. Now, today, as the title of my talk implies, I am not going to talk about all the remineralization methodologies because we've been hearing it over and over. And I know that in this conference, you will hear a lot of remineralization methods. And you have been hearing about fluoride. So I'm not going to talk about fluoride, even the new growing silver diamine fluoride. I won't talk about it. I just want to talk about those things that are developing newly for remineralization, which has not been globally known, but they are already in the market in America and Europe and Canada. And it may be, so some of them may have got to India, but I just want to touch on the newly developing remineralization methods. So, and I will classify what I'm going to talk into three main classes: the biofilm modifiers, the bioactive and biomimetic systems, and then the calcium phosphate system or fluoride boosters, things that are added to increase the efficiency of fluoride. So starting with the biofilm modifiers, what are the biofilm modifiers? We all know that biofilm can play a useful role to promote remineralization by serving as a reservoir for targeted delivery of the reminerizing agents to the lesion. This is something some people do not know, because when we talk about cleaning our oral hygiene, cleaning of our teeth to remove the plaque, people think that plaque is totally a bad thing. But some amount of plaque in our mouth serves some good purposes. Then again, we know that killing bacteria paves way for colonization. Hold on, let me put this by the side. It paves way for colonization by exogenous and often pathogenic microorganisms, which can lead to development and progression of oral diseases. So it is no good killing the normal flora in our mouth, because they protect us against the exogenous pathogenic bacteria. Therefore, the treatment should be designed to control biofilm bacteria behavior rather than eliminating them totally, because they still do some functions. So the first technology that is a biofilm modifier is what we call the Arginine Technology. The Arginine Technology is currently in toothpaste. The company producing those toothpaste is Colgate, only Colgate for now. It contains 1.5% arginine, which we all know that arginine is an amino acid, which can occur naturally in our saliva as well as in food. It also contains some amount of fluoride and the calcium carbonate. So the way it works is that the arginine in toothpaste, when you use it, there are some arginolytic bacteria in our mouth which expresses an enzymatic system called the arginine deaminase system. So they express this arginine deaminase system, which is an enzyme. Are we okay? So the enzyme, the arginine deaminase enzyme, we enzymatically break down the arginine to produce ammonia and ATP. The bacteria uses the ATP as a source of energy for growth, but the ammonia that it releases, we know that ammonia is highly alkaline, so it will neutralize any acid in oral environment, and also raises the pH of oral environment to always keep the pH of the oral environment to neutral. And we know that the neutral environment will promote remineralization and also promote a healthy biofilm. So the biofilm will no longer be destructive, that is cause demineralization. Rather, when the acid is produced in the biofilm, it will be quickly neutralized by the ammonia in the biofilm. So this is the system by which the toothpaste works. Once you use it as your routine toothpaste, it keeps your oral environment always at a neutral pH to promote remineralization and inhibit demineralization. So when if you are using this toothpaste as your normal toothpaste, you will see that anytime you eat, if you look at here, you see that when somebody eats, the red line is how much your pH will be depressed, causing demineralization once it crosses the 5.5 pH, which is the critical pH of the acid enamel dissolution. But if you are using this toothpaste that contains arginine, if you eat, your pH will no longer be depressed to the point of demineralization. It may not even go up to down to 5.5. So you will not have demineralization at all in many cases if you are using it routinely. So that is the essence of this, the advantage of using this Arginine Technology toothpaste. It promotes remineralization and inhibits demineralization. This is a study that was done with the toothpaste for 6 months. You can see that after 6 months, the size of the lesion for those group in Arginine Technology, the size of the lesion were reduced by 51%. The group using only fluoride toothpaste, the size of the early lesion in their mouth was reduced by 32%, while those using a toothpaste containing only calcium carbonate, the lesion was reduced by only 11%. You can see it here. This is the baseline. And then after 3 months, this is the reduction in the size of the lesion. And then 6 months, you see the level of reduction here. And this is the toothpaste that contains the Arginine Technology. It's available in Europe, Canada, and US. So I will go into the next group called the bioactive and biomimetic agents. First of all, we have to know that a bioactive agent is any material that can actively stimulate or direct specific cellular or tissue responses, or both, or can control interactions with microbiological species. So any agent that can do this is called a bioactive agent. And before we start, we have to realize that although saliva is supersaturated with calcium and phosphate ions in bioavailable form, the remineralization process by saliva is very slow and insufficient. Fluoride, on the other hand, can reverse initial caries and its effectiveness increases with dose. But there is a limit to which the dose can be increased to avoid fluorosis in children and toxicity in all ages. So because of that, we need material that can do the remineralization without the materials that we can increase the dose to achieve full remineralization without any toxicity. Again, we should realize that fluoride remineralization is most effective at the surface of the lesion. High fluoride, if you increase the dose to high fluoride concentration, it will induce lesion surface lamination. This is what we mean by lamination here. You can see that once you apply a high fluoride concentration agent to remerinerize an early demineralization, early caries, it goes quickly and highly remerinerize the surface of the lesion. And once it reminerizes the surface of the lesion and close all the pores, the mineral ions will no longer go in to achieve full remineralization of the entire lesion. This is why the orthodontists are finding it difficult to remineralize the white spot lesions that form after fixed orthodontic treatment. You know, after fixed orthodontic treatment, the patients develop white spot lesions around the orthodontic bracket because of inability to brush their teeth properly for that 2 years of orthodontic treatment. Now, that white spot that develop, the dentists, some of them will quickly put fluoride vanish in order to remineralize it, but it will still, although the lesion will be arrested, but it will, the whiteness will still be there, causing unaesthetic appearance. So obviously, this is what is happening. Once they apply the high concentration fluoride vanish, it quickly remineralizes the surface of the lesion and block the pores. So the mineral ions can no longer go in to give food, to remineralize the inner part of the lesion. So we want something that we go in and give us full remineralization of the body of the lesion so that the white spot will go. So there is need for agents with an ability to effect full lesion remineralization, and which those can be increased from a more efficacy without any risk. So the first one I will mention to you is what we call self-assembling peptides. This is protein. These are peptides which was manufactured in form of monomer. When this monomer is applied on early caries, the soft surface layer, it assembles under ionic strength into templates, into scaffolds. It forms the scaffold, and this scaffold will now attract calcium and phosphate ions and fluoride. It can attract fluoride ion, calcium ion, phosphate ion from the surrounding fluid, from saliva, from toothpaste, from mouth rinse, anything that has these mineral ions, it attracts it from there and use it to form hydroxyapatite. So it can be used to regenerate enamel and dentin. Any early caries in enamel and dentin, you can use these self-assembling peptides to remineralize them. So this is a study, 3-month study that was done with the self-assembly peptide. This is, it was applied together with fluoride vanish. That is, you put the self-assembly peptide, apply it first, and it's soaked into the lesion, and then you apply fluoride vanish. You can see the level of lesions, the lesion that was regressed, that is remineralized. You can see the level here. The lesions that get arrested, you see the level, and the lesions that progress, you can see the level, very low, low level of lesions that progress. Now, compare it with the second group in the study where they apply only fluoride vanish. You can see that the lesion that regress, that is remineralized, is low compared to when self-assembly peptides was applied. Because what is happening here is that the self-assembly peptide was using the fluoride from fluoride vanish to give full remineralization of the lesion. And this is a clinical case. You can see it started with this white lesion. Then after 270 days, the white spot almost vanished. And this is another study that was done, which we monitored with Canary system. Canary system monitors the hardness of the lesion, the remineralization of the lesion. You can see that control has no, gives a number. The number, the higher the number, the more the demineralization. And when the lesions start reminerizing, the numbers start falling. The Canary number will start falling, showing that it is regaining mineral. The tissue is getting harder and harder. So you can see the control where nothing was applied. And here, this is where this is placebo. And then the one that received self-assembly peptide, you can see that within 50 days, the lesion get remineralized. So the Canary number started going down, showing that the lesion is getting remineralized. So the next thing is the hydroxyapatite. Many of you may have seen toothpaste that are made totally with hydroxyapatite, no fluoride. Hydroxyapatite is a bioactive ingredient, which it can be applied in microcluster, or it can be in nano hydroxyapatite, that is nanocrystalline forms. And they can be in toothpaste. It is available in toothpaste and also in mouth rinse. The mechanism is that the hydroxyapatite has a high affinity to tooth tissue, because you know that our natural tooth is made up of hydroxyapatite. So it has the synthetic hydroxyapatite in toothpaste and mouth rinse has a high affinity to tooth tissue. So it strongly adsorbs on enamel and dentin crystallized surfaces. And by so doing, a product that has hydroxyapatite has a multifunctional purposes. It can induce remineralization, it can inhibit demineralization, it can be used to relieve hypersensitivity, it controls biofilm to reduce gingivitis. So because the hydroxyapatite is highly biocompatible, that is, and there is no limit to the dose that you can put in products. The higher the dose, the better the reaction. So this is a study we did with a children's toothpaste made for children. And we started with an early caries. You can see early lesion here. And after 28 days of the volunteers carries enamel block, which has early caries. So they use this toothpaste for 28 days. And after 28 days, we clean the block out and examine it with transverse microradiograph. You can see the level of remineralization just for 28 days. With 5%, the toothpaste contains 5% hydroxyapatite. This is another study that was done with children's toothpaste. This toothpaste is from Germany. We did this for only 14 days. It contains 10% microcrystalline hydroxyapatite toothpaste. We started with this level of lesion. Then after 14 days, this is the hydroxyapatite. You can see the level of remineralization. And fluoride, the group that use fluoride, you can see the level of remineralization in the group that use fluoride. And you can see that the fluoride has a highly mineralized layer, which is that lamination. So the mechanism by which the hydroxyapatite works is that it works like the self-assembly peptide. It enters and directly fills the micropores in demineralized tooth surfaces. And inside that tooth tissue, it acts like a crystal nucleus or template and promotes crystal deposition and growth by continuously attracting the calcium and phosphate ions from the surrounding reminerizing solution. Reminerization solutions can be mouth rinse, toothpaste, and the saliva. Anything that has calcium, phosphate, and fluoride around, it will attract the calcium and phosphate into the tissue, just like the mechanism by which the self-assembly peptide works. So it goes into the pores and it nucleates the reminerization in that area. So again, another mechanism by which it works is that when you use it, it elevates the calcium and phosphate ion, the concentration of calcium and phosphate ion in saliva and in the plaque. So the environment will be highly saturated with calcium ion and calcium and phosphate ion, which will obviously inhibit dissolution by acid. It also acts as calcium and phosphate ion reservoir in the plaque, so that during during remineralization, those ions will be used to promote remineralization of any existing lesion. And also, they found out that when it is applied, it attracts the bacteria to itself. It attracts bacteria to itself, thereby in promoting co-aggregation of the bacteria, so that the bacteria will form co-aggregation and get swallowed with saliva. So it can reduce the level of bacteria in the mouth and the plaque by inducing this co-aggregation, leading to the swallowing of the bacteria and reduction of bacteria in mouth. And by so doing, it relieves gingivitis and periodontitis, and also inhibit biofilm formation. So another new product I will talk about is what is called the surface pre-reacted glass ionoma filler. We know that when you combine strontium and fluoride, it enhances the efficacy of fluoride to promote remineralization compared with fluoride alone. And this is what prompted this group to develop this particular material. What they did, they developed a glass ionoma filler which can release multiple ions. It can a total of 6 ions. It can release fluoride ion, boron ion, sodium ion, strontium and aluminum ion, and silicon dioxide ion. And by releasing this ion, they found that it has all these functions: antibacterial effect, anti-plaque effect, promotes remineralization, increases the resistance of the tooth to demineralization, and also it has acid buffer function. So it can perform these 5 functions when it is applied into any product. And what they did here was that they have a glass ionoma core, which they pre-treated the surface and then pass it through a polyacrylic acid aqueous solution, which contains all these ions. So they get imbibed into this glass ionoma phase in the middle here. And then when it is exposed to when it is put in any product, it releases ion when it's inside the mouth. So when it is used for a study that was done with the toothpaste or mouth rinse that contains this shows this is a remineralization study. You can see that they measure the micro hardness of the early caries. This is for the distilled water, the one that was treated with distilled water, there was no effect, no increase in hardness of the early caries. But the yellow is the one that was treated with sodium fluoride toothpaste. And the ones that were treated, the lesions that were treated with toothpaste containing the SPRG fillers, the 5% and 30%, you can see that the hardness, the micro hardness of the lesion keep increasing over the months, showing that it's promoting remineralization. This is a study we also did with the toothpaste. You have to prevent demineralization we check it with a quantitative light-induced fluorescence. You can see that this is control, no toothpaste. This is sodium fluoride toothpaste. You can see the demineralization there, 0, 0, the one toothpaste containing 0 SRP. You can see equal demineralization as in control. 1%, you can see the level of demineralization, and it keep going down. 30%, you can only see the demineralization with the QLF, but visually we couldn't see demineralization visually.
Dr. Amechi, we are not able to hear you. I think his connection is cut. Okay. Yeah, he's here.
Yes, ma'am. I think.
Dr. Bennett, you're
Not audible.
You're not audible now. You need to unmute yourself first.
Okay. Can you hear me now?
Yeah, I can hear
Yes,
you.
yes,
We can
yes.
hear you, but your screen sharing has now stopped. I mean, your screen is
Okay.
not visible.
So, okay, no, okay, let me. Can you see my screen now?
Yes, yes.
Yes.
Okay.
Yeah, this is the same slide we were on. Right.
Okay.
Please go ahead.
All right. So this is the second study we did, and we're using microbial caries model. So in this particular one, we use plaque. Our microbial caries models, our artificial mouth that generates natural plaque. And you can see different percentages of the SPRG filler. You can see the 20% inhibited, they all inhibited demineralization to various degrees. And here, below here, you can see that just like the first study, it inhibited demineralization by 73% when it is 20% filler. So in general, the way it acts, is that the mechanism by which it acts is that it has acid buffering capacity, ion release and recharge. That because those ions that were being released, the glass ionoma phase that is releasing this ion can be recharged. Anything that carries this ion that you put in your mouth, like mouth rinse and toothpaste, can recharge the glass ionoma back again with those ions. So it will start releasing it again. So it can release and get released and recharged again. So it has remineralization effect. It can strengthen the tooth structure, like fluoride and strontium when they get, and boron, when they get diffused into the tooth structure, they increases the resistance of the tooth to demineralization. It also does it by formation of acid-resistant layer. It has antiplaque and inhibit enzymatic activities in bacteria. So there are so many studies that shows that it does all these things. And they have it in these products. They have it in vanish form, in fluoride vanish. They have it in restorative material, composite restorative material. They have it in sealant, pit and fissure sealant. they have it in what they call cell, PRG barrier cell. When during orthodontic treatment, you can paint it around the bracket so that demineralization will not occur around the bracket. They have it in toothpaste. Then they incorporated it into this material. So when you use it to form this mouth guard, they incorporated into this mouth guard material. So if you use it to use the material to form this mouth guard, people can use it. And people that are swimming in acidic swimming pool, ill chlorinated swimming pool that usually cause erosion on their teeth, or people that if they wear it and eat anything acidic, it will not, it will neutralize the acid while they're wearing this. So they have it in all these materials. So the next thing I have to talk about is what we call ear. It's electrically accelerated and enhanced remineralization. It is an equipment, a small electric field generating equipment. What it does is that when you, if you have early caries on the surface of the tooth, you apply the agent you want to use to remineralize it, either fluoride vanish or toothpaste, any agent you want to use, that you have the remineralizing agent you want to use. And then you apply this material on the surface of that, tooth, on top of that agent, and it generates electrical field. The electrical field will now drive the ions, the mineral ions. It drives it directly into the lesion and cause full remineralization of the lesion. So it uses electrical field. They call it iontophoresis. By that mechanism, it drives the ion directly into electrical equipment to apply the material, you either toothpaste or fluoride vanish or anything you want to do the remineralization, and then apply the electrical field, and it drives the ions directly into the lesion within few hours. So no anesthesia injection is required, no drilling required. The remineralizing agent can be either hydroxyapatite or similar materials, which you paint on the surface of the lesion and then use the electrical field to drive it in. So it is just coming into the market. This is a sample of the lesion that it was treated, and then they examine it with micro CT. This is the size of the lesion before treatment. After 3 minutes of application of ear, you see the lesion started shrinking, and then this is the level after a longer treatment. And this is they examine it with scanning electron microscope. This is untreated lesion. You can see that the enamel broken in and demineralized enamel rods. This is a healthy enamel. Then this is ear-treated lesion. If you compare the enamel structure in the healthy enamel to that treated with the ear, you can see that it's almost the same thing. So the simple thing is that they use that electrical field to drive in the ions, which is the problem we have in remineralization. Anything we can use to get the ions into the porous early caries. So the next one is the new technology in the market now called Lumechia Technology. Lumechia Technology uses a submicron starch particles to carry ions, calcium, fluoride, phosphate ions. They carry the ions into the lesion. So this is an active lesion. This is the solution containing these particles. They load the particle with any ion they want to use, fluoride, calcium, phosphate, and it's in form of liquid. And then the person will use it to rinse mouth. When you use it to rinse mouth, then it diffuses into the lesion. By the particle diffuse into the lesion and then carry with it, it will carry the ion, the fluoride, it will go there and deliver the fluoride, the calcium, and the phosphate. Now, it is not only for remineralization, actually, they can also carry something, a fluorescent, they can incorporate a fluorescent device into it, a fluorescent cation, which will show you the lesions. If you paint it, if the patient use the liquid to rinse their mouth, then you use just your curing light. The curing light you use in curing your composite. You shine that light on the tooth surface. Any active early caries, the liquid, those particles will imbibe into those lesions. And then if you shine the light on it, they will fluorescent and show you that these lesions are active. Now, what they did, they started by using it as a caries detection means. But now, since they see that it can go into the lesion, they thought, okay, we can then use it to carry the mineral ions, fluoride, calcium, and phosphate into the lesion too. So they now have it, they now mix it, both the fluorescent particle together with fluoride, calcium, and phosphate. And when the patient uses it to rinse mouth, it will penetrate into the lesion and arrest the lesion and remineralize the lesion. So this is the newest device in the market now. Then we go into, these are the bioactive and biomimetic system that we finished now. Then we get into the fluoride boosters. The fluoride boosters, just as I said, although fluoride intervention seems to have the most consistent benefit in preventing caries and remineralizing initial lesions, caries can still develop in high-risk individuals. Hence, there is need to enhance fluoride effectiveness. So efficient ways of increasing product effectiveness while limiting fluoride dose to avoid the potential risk of fluorosis is necessary. So what they use, they use now is what we describe as polyphosphate systems. That is having multiple phosphate systems. And the three popular ones is the sodium trimetaphosphate, calcium glycerophosphate, and the hexametaphosphate. For example, the sodium trimetaphosphate, it strongly binds to the phosphate site on enamel surface to form a protective layer on the enamel surface that limits acid diffusion of ions during the choriogenic challenge. So it forms a layer that limits the diffusion of acid ions into the tooth tissue in order to demineralize the crystals. So this layer does not seem to hinder the diffusion of calcium and fluoride ions into the enamel. It only hinders the diffusion of acid ions, the acid, and not the calcium and fluoride or phosphate ions. So when delivered from the toothpaste, its ability to elevate the plaque calcium concentration is the predominant mechanism by which it works. So these are the studies that shows that they used in demonstrating the efficiency of this polyphosphate method. So in this particular study, they combine only 5 ppm level of fluoride, which is low fluoride dentifrice. They combine it with the STP, and you have the effect. The effect you get is the effect you get with 1100 ppm fluoride. the level of reminerization you get is the level of 1100 ppm. Meanwhile, you have only 500 ppm of fluoride there, but because you combine it with this STP, STMP, you get the effect of 1100. Then the conventional 1100, you know, the 1100 ppm fluoride is the level of fluoride in our toothpaste in US here. So the conventional 1100 ppm toothpaste or fluoride vanish, if you combine the fluoride vanish with this, or with either fluoride vanish or 1100 ppm toothpaste, you get an enhanced reminerization. Then for the 1100 ppm fluoride plus the hexametaphosphate, nanoparticle hexametaphosphate, you also have enhanced reminerization, which is as if it is the high fluoride toothpaste. Instead of giving the person using a high fluoride concentration toothpaste like 5000 ppm, you use 1100 combined with these polyphosphates, then you have an enhanced the level of reminerization you have is the level you can get with the 5000 ppm. Instead of taking the 5000 ppm, which is a high level of fluoride, you can use the one that was combined with this and you get the same effect. This is a clinical trial, randomized clinical trial of that 500 ppm low fluoride dentifrice combined with the calcium glycerophosphate. You have the effect of 1100 ppm toothpaste. Also, this one, the same 500 combined with STP, you have the level of 1100. Meanwhile, you have only 500 ppm. So in this case, you can give this to children in order to have an enhanced caries prevention or enhanced reminerization in children. So addition of the polyphosphate in conventional 1100 ppm fluoride toothpaste gives you enhanced reminerization. Addition of the polyphosphate in low fluoride toothpaste may be considered a safe alternative to the conventional formulation for children under 6 years of age based on their risk-benefit assessment. So this is the toothpaste that contains this polyphosphate for now, Oral-B toothpaste Pro Expert. So it is currently in the market. Okay. So this is the end of my presentation. I was trying to avoid, because it's only 50 minutes, I was trying to limit what I put in there. I hope I did not exceed my time.
No problem. No problem. Thank you. It's been an amazing time listening to you. And I think our sincere thanks on behalf of the organizers of CADRE 21 for staying awake at almost it's midnight there. And thank you for being flexible to make it comfortable for us in India. It's a big flexible. Thank you for that to start with. And in terms of the presentation on remineralization, I just thought I'll quickly summarize the way you started with defining remineralization, bringing back minerals from the environment to the tooth in various ways. And you've outlined three broad major technologies or changes which is bringing in so much of technology or changes in to remineralization. The first one was the biofilm modifiers. To honestly tell you, all these things are absolutely new knowledge for me as a personally, majority of the things. So the biofilm modifiers, you explained in detail the Arginine Technology. I think probably the toothpaste should come soon to India, I guess. Looks like we will have a version of toothpaste 2.0, 1.0, 3.0, like that, the way the technology is going. And amazing to see how the biofilm modifiers use Arginine technology to eliminate microorganisms and promote remineralization. And you also explained in detail the various bioactive and biomimetic systems, which kind of stimulates a specific cellular or tissue response or control microorganisms. And you talked about few very important points in that categories of information. One is the self-assembling peptides, and then hydroxyapatites, then surface pre-reacted glass ionomers, and then electrically accelerated and enhanced remineralization. So it's amazing to see here all these new technologies and how they work, either promoting remineralization or favoring or altering the environment in the oral cavity. And lastly, you also added fluoride boosters using the polyphosphate systems, using sodium trimetaphosphate. And another interesting thing, which was the Lumechia technology on the biomimetic systems itself. So thank you for an amazing and enlightening presentation on various aspects and the latest trends in remineralization. I have, before I go to the questions from the participants, I have a couple of questions on that. I'll start with that, then I'll look at any questions from the participants. One is where are we in terms of using this technology in children? Is there any cutoff is there in terms of usage in the age group less than this much? You cannot use these advanced methods of remineralization. Is there anything like that? Is there, Professor Bennett?
No, there is no age limitation in any of them. There's no age limitation. In fact, the main purpose of one of the purpose of developing these technologies is because the fluoride, which is the main thing we use in remineralization, you cannot use a high dose in children. Yes. And yet we see caries in children, in high-risk children. So we want something that you can use to prevent caries and also to enhance remineralization in children without fluoride, without high level of fluoride. So there's no age limit in any of them.
Okay. That's great to hear and very encouraging for me as a pediatric dentist, Prof. And there's another question in the chat window. I'll come back with my next one later from Dr. Mahalakshmi. What about the biocompatibility of the polyphosphates?
Oh, the polyphosphate, they are highly biocompatible. That is when I say that they bind strongly to the surface of the crystals, the enamel, hydroxyapatite crystals. That is biocompatibility. They can diffuse well into the lesions and abide to the surface of the crystals. They can also absorb very well to the surface of the tooth to form a protective layer. So they are very biocompatible.
Okay, Professor Bennett. And overall, it looks like in efforts to control caries, largely we are trying to alter the environment in terms of saliva or the various mechanisms by which we alter the pH or control the plaque or control the microorganisms. Being spent so much time in this area, what do you think the role of tooth surface per se in terms of the inherent integrity of the enamel? What's the role, whether they will respond differently for these remineralizing agents in different way between people, depending on the inherent integrity of the enamel? Would you like to add anything on this, Prof. Bennett?
We have not seen any difference on the reaction of the enamel to all these remineralizing agents. There has not been any difference. because most of them are biocompatible and they are many of them are biomimetic. They go in there and they starts a reaction which help in developing a new hydroxy or fluoroapatite. So there has not been any difference in enamel. Rather, some of them like the surface prereacted glass ionoma, when the fluoride and the strontium and boron combine together and get into the tooth tissue, it enhances the resistance of the tooth tissue to demineralization.
Okay, thank you, Prof. I may request Dr. Sangeeta to continue with the other questions.
Dr. Amechi, your research statement that fluoride treatment is still the standard therapy for remineralization of carious lesions is still acclaimed world over. So a question which has come up is what is the future of fluorides in the current trend of modern remineralizing agents? This question has come up from the audience.
Yes, that's a very great question, because we know that fluoride is the gold standard for remineralization. And any reminerizing agent, any new reminerizing method that is developed, fluoride is used as the positive control to assess the efficacy of the new developed agent. So fluoride will never die. The thing is that fluoride has not been able to do it all. Anything that is being developed, the search is for something that will work better than fluoride, or something that can work synergistically with fluoride to get an enhanced remineralization. But upon all these things, from what I presented here, you can see that the only one you can say that it is far better than fluoride is the electrically driven one, which pushed everything inside instantly. But yet, it still needs fluoride to do it, because it's simply a mechanical way of pushing in the fluoride and other mineral ions. So fluoride will still be there, but we are looking for something. We are still looking for something that will be better than fluoride or work together with fluoride, because fluoride has not been successful in eliminating caries or doing full remineralization.
Okay, thank you so much.
Dr. Muthu?
Yes, ma'am. Are there any questions from the participants? Any other questions from any?
Yeah, there is one which I posted for you. They're just posting it to you.
Yes, ma'am. And can you compare, Professor Bennett, there's one more question on here. Can you compare the efficacy of application of the paste when used alone and in combination with laser, which is more effective?
Obviously, the laser, people have been using laser to promote remineralization. But the fear we are having about laser is that the laser, people we are seeing that what laser is doing is that, first of all, it will melt. It modifies the structure of the tooth. And some people were seeing that it melts the crystals and we melt it together with the agent that you applied. And when you melt the crystals, you modify the structure, some end up being more resistant to demineralization. Obviously, it's an advantage, but nobody knows the long-term effect of when you are modifying the structure of the natural structure of the tooth by melting it with laser. That is the fear people are having about laser.
Okay, Professor, thank you very much for your detailed explanation on the questions. I'll pass the mantle to the organizers.
There are a few more questions. Can we take it up, Dr. Bennett? Are you okay with a few more questions?
Yes, yes.
5 minutes. There are a few more.
Dr. Mahalakshmi, I'll take up another question which is there from the audience.
Yes, there are questions coming in. I'm just putting it for you all.
So, Dr. Bennett, one question which has come up is what is the level of evidence for pure remineralizing agents compared to the gold standard fluoride? You see, currently, mostly there are in vitro studies, and a lot of randomized clinical trials are also on, and outcomes are being assessed. So what is your opinion in this regard?
All these new products that are being developed, none of them has ever got as much evidence as fluoride. You see, none of them has got as much evidence as fluoride. And some of them have not even got more randomized clinical trials. Many of them have not gone through randomized clinical trials. But you know what is in dental area? There is no too much strict law about marketing some of these products. For example, in US here, we have what we call pre-marketing authorization. They can go to FDA and have pre-marketing authorization to market the product. So they go ahead and start marketing it without doing clinical trial, because clinical trial costs them a lot of money. So many companies are avoiding it. So there is no strict law that prohibits them from selling these products without big clinical trial. So fluoride still have more evidence supporting its efficacy compared to these products.
Okay. Thank you, Dr. Amechi.
There's another question here, Professor Bennett. Whether active lesions are more remineralizable than non-active lesions?
Active lesions? No, I didn't get the question.
Yeah, whether the active lesions are more remineralizable than non-active lesions.
Oh yes, active lesions are more remineralizable because active lesions are porous. Active lesions are porous, so mineral ions can get in and get it remineralized. But non-active lesions have the surface is already remineralized and blocked the entry of more mineral ions. So it is easier and more effective to remineralize active lesions than inactive lesions. In fact, there's some people have done a study to promote the remineralization of inactive lesions by etching it, putting etchant, the phosphoric acid etchant. They etch the surface of the inactive lesion in order to open the pores. So to enable and when you etch it and open the pores, you automatically made it active in order to enable it to be remineralized, because the inactive pores, the surface has already been blocked. The pores has been blocked, so you can never get any mineral ion inside it. And also that was the reason why they now have all these acidulated products. There is growing production of these acidulated mouth rinses and even toothpaste, they are getting it acidulated because if it's acidulated, when you use it and rinse your mouth or brush your teeth, it mildly etches the surface of the teeth and open the pores in order for mineral ions to go in. And that is particularly important for non-active lesions. You know, we have what we call APF, acidulated phosphate fluoride. That is the mechanism by why they form it. Because if you paint it, it will etch the lesion and open the pores for the mineral to go in.
Dr. Sangeeta, can you ask the last question, please?
Yeah, Dr. Amechi, one last question which has come up from the audience is like, which method or tool do you consider best for assessing the clinical outcome after remineralization? Basically, we would want the white spot lesions to normalize color-wise. So do you think visual inspection is enough, or we require additional aids for this purpose?
You mean method for monitoring the remineralization?
Yes.
Yes.
Okay.
Yeah.
So you are asking about a method for assessing the remineralization during the treatment. Yes, that is a very big problem in cardiology today. What the technology we can use, apart from the eyes, technology we can use to monitor the remineralization and say that objectively that this lesion is gaining mineral. It is still difficult. Look, right now we have a technology in the market called Canary system. Then that is the only thing. Okay, you can see the quantitative light-induced fluorescence, but it's not efficient because so many factors affect its efficiency. So right now, I can tell you there is no technology that effectively monitors remineralization.
Okay. Okay. Thank
you. Thank you. Thank you very much, Dr. Bennett. Can you please stop sharing the screen, please?
Okay. Let's see.
Thank you very much for that exhaustive, as usual, presentation of yours, Dr. Amechi. I now call upon your longtime friend, Dr. Satya, to do the honors of the certificate. Dr. Satya Kumar, take over, please.
Sir, good morning, sir.
Okay, how are you?
Thanks, sir. How are you, sir?
It's been a long time.
Very, very long time, sir. I don't know if it's good morning or good night for you, sir. It should be a good night.
Oh, well, it's good morning now.
Happy to see you, sir. Very, very
Yes.
happy.
Good to see you again.
Yes, sir. Thank you. Thank you so much. And as usual, your topic is enlightening to everyone in CARE's research. So thank you so much. So on behalf of CADRE 21, I'd like to honor our chief guest speaker, Bennett Tochukwu, with a certificate of token of appreciation, sir. Please accept our token.
Thank you so much. Thank you.
Definitely we'll keep in touch with you, sir.
Thank you.
Lot of questions are there. I don't know, we can discuss, we can discuss separately, sir.
Okay. They can always, you can always send me email with any questions.
Yes,
Sure, sir.
actually,
Sure, sir.
we had a lot of questions, but we just stopped at this because we are eating into the time of the next speaker. Thank you, Dr. Satya, for honoring Dr. Amechi. Thank you, Dr. Amechi, once again. And our appreciation to the chairpersons, Dr. Sangeeta Talwar and Dr. Muthu, for your wonderful moderation.